Alright, what's up guys? In this video, I'm going to pick up some calculus here. We're going to be talking about infinite series again. And today we're going to be talking about the comparison test. So we just want to use the comparison test to determine if the given series converges or diverges. So this is the series that we're given from k is equal to 1 to infinity. It's 1 over k multiplied by k plus 1. Okay, so very quickly, this is the comparison test. Okay. So basically what it says is, it says that let a series a sub k and b sub k be a series with positive terms, non-negative terms. And we're asked to suppose that our series b sub k is going to be greater than or equal to a sub k. And basically what the comparison test says, it says that if our larger series, b sub k converges, then our smaller series, a sub k, will converge. And if our smaller series or our original series, a sub k, diverges, then our larger series, b sub k, will also diverge. Okay. So to deal with problems like this, as with anything, it takes practice. So we need to find a larger series that we can compare our original series to determine the convergence, and that's basically what the idea is here. Also, keep in mind the comparison test does not work all the time, and you may have to resort to using the limit comparison test in some cases. So just keep that in mind. So you just need to get a feel for how the series terms behave. Okay, so here is our original series. We could say that a sub k for our original series is going to be 1 over k multiplied by k plus 1. So that's our original series. We need to pick a comparison series. So it seems to me that the series terms behave like 1 over k raised to the second power. Okay, so our larger series is going to end up being where b sub k is equal to 1 over k squared. Okay. All right. So the question is, does our larger series converge or does that diverge? Well, hopefully you can easily see that this clearly converges by the p-series test, because remember that if I have a series, let's say it's 1 over n raised to the p, for example, but it's important to keep in mind that if p is greater than 1, it converges. And if p happens to be less than 1, then it diverges by the p-series test. So we can clearly see in our case that p here is 2. Obviously 2 is going to be greater than 1, so it's going to converge by the p-series test. Now, since our larger series b sub k converges by the p-series test, well, then that must mean that our original series from k is equal to 1 to infinity, 1 over k times k plus 1, is going to end up converging as well. So for our final answer for this, when we pick a series to compare it to, a larger series, since that larger series converges by the p-series test, then we could say that our original series, or our smaller series from k is equal to 1 to infinity for 1 over k times k plus 1, is going to converge as well by the comparison test. And that is going to be your answer. So in order to do problems like this, you need to get familiar with how the series terms behave and pick a series that you can compare the original one to, so that you can determine the convergence or divergence of a particular series. Okay, all right, so if you guys got any questions, I'll be more than happy to answer them. I will see you guys next time.